So chapter 2, section 2, it's analyzing conditional statements. We are going to have quite a bit of vocabulary in this lesson. You're going to need to know what a conditional statement is, what a inverse, what a biconditional. We're going to see all the vocabulary words momentarily. Okay, so the first thing is a conditional statement. And a conditional statement has two parts. It's going to have a hypothesis and a conclusion. The hypothesis is represented by the letter P. The conclusion will be represented by the letter Q. Okay, on the quiz, you will have to write a statement in if-then form. If-then form, another name for that is a conditional statement. But on the quiz, it's going to state, write this sentence or statement in if-then form. So here, in my conditional statement, you study is the hypothesis. And then the conclusion is you will get an A. So if you study, then you will get an A. This is an example of a conditional statement, and it's written in if-then form. Later on, we're going to see shortcut version of this, where they're going to take the P and the Q and they put an arrow. And what this means is if P, then Q. Everybody good with this slide? Anybody still need it? Okay. Good? Anybody else need it? All right. Next, we're going to talk about the negation of a statement. Now, another word that we could use here is the opposite of the original statement. So basically what you're going to do is either you're going to put in the word not or take the word not out. So you're either going to, if it's already negative, you make it positive. If it's a positive statement, make it negative by adding in the word not. So for example, my original statement here is, it is raining. And then the negation or the opposite of that would be, it is not raining. Another example, the shirt is not red. And then the negation of that would be, the shirt is red. So not a lot of math here. This is just logic. It's going to be understanding the terms. Everybody good on this? Anybody still need it? Okay, next term we're going to encounter is converse. So what we're going to do when I ask you to write the converse, we're basically going to flip-flop the statement. The hypothesis will go to the conclusion, and the conclusion will go to the hypothesis. So my original statement was, if you study, then you will get an A. If I flip it, and I now state the converse, it states, if you got an A, then you studied. So you're flipping it around. The if goes to the then, and the then goes to the if. And that is the converse. So on the quiz, I will give you an original statement, and I will ask you to state the converse. And you just rearrange the words. Everybody good on converse? Okay. The next thing we're going to talk about is the inverse. So this is formed by negating both the hypothesis and the conclusion. So we're going to add in some nots, or just make it opposite. So here, if you study, then you will get an A. That was the original statement. To inverse that, you would say, if you didn't study, then you didn't get an A. So we're making it opposite or inversing. So again, understanding the words is what this lesson is all about. Everybody good on inverse? The next one, contrapositive. Okay, this is like the biggest word out of them all. So this is where it's going to involve a lot of work. So the first thing we're going to do is make the original statement into the converse. Then negate both the hypothesis and the conclusion. So basically make it the converse and then do the inverse. So again, my original statement, if you study, then you will get an A. Remember, the converse is to flip it around. So if you got an A, then you studied. And then we negate both of them. So if you didn't get an A, then you didn't study. So contrapositive, you're going to first flip it around, make it the converse, and then negate both the beginning and the end. Anybody still need this slide? Okay. Lot to write. Yes. Yes, question? Okay. Pretty good? Okay. Any questions on what a contrapositive is? So you'll be given the original statement called the conditional. It'll be written in if-then form. Then I might ask you to give me the converse, and you'll flip it. I may have another question where it'll say, give me the original statement, give me the contrapositive. So you flip it to the converse first, and then you negate. Everybody good now? All right, next one. Okay. And an if-then statement is false when you try to find an example that proves it, that it shows that it's false. It's called giving a counterexample. So, for example, here is my if-then statement. If you live in Florida, then you live in Miami. Is that a true conditional statement? No. Can someone provide me with a counterexample? Yes. Good. If you live in Florida, then you live in Tampa. So it's not Miami, it's now Tampa. Anybody have another one? Where else could you live in Florida that's not Miami? In Orlando. Good. So basically any other city in Florida would prove it false. Anything other than Miami. You could say Davie. You could say Southwest Ranches. Yes?
What if the conclusion was also true? Maybe there's a true, which is called a true statement.
It all depends. Sometimes the whole thing would be true. Okay? Like another example. Like let's say I told you, if you're the quarterback, then you're on the football team. Is that a true statement? If you're the quarterback, then you're on the football team. True or false? True. Okay? I said, if you are on the football team, then you're the quarterback. False. Give me a counterexample.
If you're on the football team, you are running back.
Okay, there you go. So any other position other than quarterback would be your counterexample. So sometimes the original one is true, but then when you make it the converse, it's not. And we're going to see that in a minute, and this is going to be one of the conditions to write the next thing that we lead into, called a biconditional statement. So in order to create a biconditional statement, both the original statement and the converse both have to be true. So in the statement about Florida, that we couldn't do. Okay? In my football example, we could not write a biconditional. Generally, a biconditional, you could come up with a biconditional for like a rule or a definition. So for example here, if an angle has a measure of 90 degrees, then it's a right angle. Okay, can someone tell me the converse of that? Isabella.
The angle is, a right angle has a measure of 90 degrees.
Okay, so if, I'm going to write it backwards, so I'm going to put this first now. If it is a right angle, then it has a measure of 90 degrees. So this would go first, and then the beginning part goes to the end. And that would be your converse. So now that I've written, so we've already said that the conditional statement was true. Is my converse true? Yes. So because it's true, I can now write another statement called a biconditional statement. And I'm going to include the words if and only if. And here's how we're going to write it. We're going to drop the words if and then, and in the middle, I'm going to put if and only if. So my new biconditional statement would be, it is a right angle if and only if it has a measure of 90 degrees. So what I'm doing is, when I make it into the biconditional, I dropped the words if and then, and in between the if and the then statement, I've added the words if and only if. Now, I can also write it from the original. So this biconditional actually has two answers. I could also write my biconditional statement using the original. Meaning I could have done an angle has a measure of 90 degrees if and only if it is a right angle. So for the biconditional, you can either do it from the original or from where you've made it into the converse. Yes?
What if when you switch it and you put if underline?
It has to be true. They both have to be true in order to write the biconditional. Okay, everybody understand biconditional? It doesn't have the words if and then separating the two things. It's going to have the words if and only if in the middle. All right, let's another example. So here's another example. If you attend AMHS, then you wear an ID. What is the hypothesis in that statement? Yes. Did you have your hand up or no? Okay. Can someone tell me the hypothesis? Jason.
If you attend AMHS.
Good. That's the hypothesis. Okay. What would be the conclusion? Yes.
Then you wear an ID.
Good. You wear an ID. That's the conclusion. Okay. First thing it wants us to do now in part B is to state the converse. Okay. What's the converse of that statement? Remember, we flip it. So the converse here would be if you wear an ID, then actually sorry. Then you attend AMHS. That's the converse. What would be the inverse? Yes.
You don't wear an ID, then you don't attend AMHS.
Good. So the inverse, we're going to negate both. So if you, and I'm going to do the inverse of the original, and then the contrapositive is the inverse of the converse. Yes.
You can inverse only one part of the statement, right?
Um,
Terms.
You could inverse, they could tell you specifically, but if it says inverse, then you're doing both. If you negate, you can negate part of it, but if it says to find the inverse, you're doing both. So the inverse of the original would be if you do not attend AMHS, then you do not wear an ID. Okay, and then for the contrapositive, I have to negate this one. So the converse. So if you do not wear an ID, then you do not attend AMHS. Now, is the converse a false statement? And this is the converse right here. If you wear an ID, then you attend AMHS. Is that true or false? Okay, can someone give me a counterexample?
If you attend Pines Charter High School, or if you wear an ID, then you attend Pines Charter High School.
Good. Okay, any other high school, St. Thomas, Pines Charter. You could even say you work at a hospital. If you wear an ID, then you work in a hospital. Or any other job or occupation that requires you to wear an ID. Does that make sense?
What does that say besides inverse? Like beyond?
Original. So I inverse the original. All right. Homework. Okay, we have one more slide. This is example 2, and it's asking us to write a biconditional with a pair of conditionals. So our first statement is if M is between L and N, then LM plus MN equals LN. Does anyone remember what this is talking about from chapter 1? This is the segment addition postulate. We are going to use this quite often in the upcoming proofs that we're going to be covering soon. Then the second conditional, for the converse of our conditional statement, if LM plus MN equals LN, then M is between L and N. We're now going to take the two conditionals, or the original conditional statement and its converse, and we're going to turn it into a biconditional, adding in the words if and only if. So to turn part A into a biconditional, we could start out by saying M is between L and N if and only if LM plus MN equals LN. We could also write it using the second statement. So this actually has two answers. We could also state that LM plus MN equals LN if and only if M is between L and N. So as long as both of our statements are true, we can turn both of the conditionals into a biconditional. We replace the words if and then, and in its place in between the two statements, we're adding in the words if and only if.